Assalamualaikum and hi everyone. So now I want to show you the step to do Holt-Winter additive exponential smoothing. So here is the table of formula and I have already inserted the data into the Excel form here. So the first step is to do the YLT plus T minus YT is equal to the quarter one of 2010 minus the quarter one of 2009 here, and then we just drag it down until quarter 4. The next one is 80, so the 80 is equals to the average of the actual number of 2009 here. After that we do the TT, so the TT equals to the sum of YL plus T minus YT divided by, so since we have each year with quarter 4, so we divide it by 4 squared. So the next one here is SD. So from the tables here we know that S1 equals to Y1 minus AL. So here S1 equals to Y1 minus AL. So from here we know that AL is always the same, so we need to lock it here, and then we just drag it down until quarter 4. So the next one is ST minus L. In 2010 must be equal or the same with the 2009 here. So here will be equals to ST here. And then we just drag it down until quarter 4. So next is the 80 from the formula table. Here 80 is equal to alpha bracket YT is here 2010 quarter 1 minus ST minus L here close bracket plus 1 minus alpha here multiplied by 80 minus 1, so which is 80 minus 1 is quarter 4 of 2009 plus the TT minus 1 is quarter 4 2009. So since the value of alpha is always the same, so we need to lock it here and also here. Enter. Okay. Then we do the TT as we see here from the table of formula. TT equals to beta times 80 minus 80 minus 1, so 80 here minus 80 minus 1 is before here plus 1 minus beta times TT minus 1 here. So it's just like the previous. We need to lock the beta value since the value of beta is always the same, so we need to lock it. log the beta value here. Okay. Then we do the SD at 2010. From the formula table, we know that SD equals to gamma times YT minus AT. So YT is here minus AT plus 1 minus gamma times the ST minus L here. So we need to log the gamma value since the gamma value is always the same here and here. Okay, and then we do the forecast here. So from the formula table, we know that forecast equals to AT, so here, plus the TT here, plus the ST minus L plus M, so here. Okay, so since all of this is done, so we need to select and just drag it down until 2019. Okay, so after that we need to do the error. So error equals to the actual value minus the forecast. And then the error square equals to the error here, and then we just carry it. Need to select both of these and then just drag it down until here. Okay. For the ST minus L, we need to drag it down until evaluation part in 2020, and the forecast part also we need to drag it down until here. But the forecast part we need to change a little bit, which is K equals to 1, 2. So here like this, 3. Okay, so here at the G47 we need to multiply by 1 here, and then we need to lock the F47 here and G47 here, because it must always be the same. Then we just drag it down until the quarter 4. Same goes to the error and the error square. Okay, so we're almost done in the forecast part here. To make sure that we choose the perfect value for alpha, beta, and gamma, we need to use the solver here. So before that, we need to find the MSE for the modeling part here. So MSE equals to average of modeling part here until 2020. Okay, and then we choose the solver. So for this part, we need to choose the MSE modeling, and then need to use until minimum by changing the variable cell, which is alpha, beta, and gamma here. And then for the subject to constraint, we need to add here star reference is here less than equal 1, then add one more, the same cell here, more than equals to 0. okay. Okay, here done, and then we just solve here. Okay, so we get the value here. So this will be the best value of alpha, beta, and gamma after we using the solver.